As an interlude before learning yet another model, we are going to talk a bit about preprocessing and pipelines. So what we are going to do in this model is, first of all, we are going to talk a bit more about preprocessing. So recall that preprocessing is everything you do from after collecting your data until you do the machine learning steps. So the preprocessing steps we are going to talk about is filling in missing data, selecting useful features and dropping the unuseful ones so that we don't have a lot of noise in our dataset. And we are also going to talk a bit about how to scale your data so that it is uniform in size. So after talking a bit about preprocessing, we are going to move towards pipelines. And pipelines is a way to collect a lot of different machine learning steps into one step. So first of all, we are going to discuss a bit more in detail what a pipeline actually is. And afterwards, we are going to learn how to create a pipeline in Scikit-Learn. So let's get started. Let us get started with discussing a bit more about preprocessing. As we have shown earlier, there are several steps in actually doing machine learning. So first of all, we need to collect the data. Thereafter, we have some exploring to do. Then we have the third step that usually includes a lot of cleaning and preprocessing. And this is the step we are going to discuss a bit more in this video. So preprocessing is everything we do to make the data ready to be trained on. So this, for example, involves dropping features that we do not think is very useful, and also it involves combining features, which we will discuss a lot more in the next module where we discuss the polynomial model. But for now, let's focus a bit more about filling in missing values. So often when we are doing, for instance, a survey or having some sensor data and so forth, we have observations that are missing some of its features. So for instance, it can be that some people answering the survey do not wish to disclose certain data. What we need for the training step to take place is that all the data need to be uniform. In particular, it cannot have missing values. So we need to do something with this missing data. One thing we can do is just drop all the observations that have missing values. And this can, for instance, be a very good idea in the case that there are very few observations that actually have missing data, or we see that the observations that have missing features have a lot of missing features. So it can be, for instance, in the survey, they just stop answering the survey after 1 or 2 questions. So that is the first way we can handle missing values, but there's also another way, which is that we can fill in the missing values, for instance, with the mean in each column. So here I have an example. So we have feature 1 here with some missing data. So here we have a missing value, and also here we have a missing value. And the same is true for feature 2, where we have a missing value here and a missing value here. So what you can do is to take the mean of all the values that are present and just fill in these nan values with the mean. Because most likely what should stand here should be the mean of all the missing features. And we can do the same thing with the feature 2 and just take the mean of all of these numbers and just fill in the missing values here and here. So another preprocessing step I wanted to discuss is the so-called standard scaler. So often our machine learning models is not invariant under scaling. This becomes a problem because, for instance, if we want to record the height, we know that there are several different units we can report it in. So, for example, we can choose to do it in meters or centimeters or feet and so on. So what we don't want to happen is that when we train the model, it will give us different answers for different scalings. So we don't want to have a completely different model if we have reported the height in centimeters compared to reporting it in meters. So we often want the data to become uniform so it doesn't affect the training step. One way to do this is with the standard scaler, which makes sure that the mean of the data is 0 and the variance is 1. So here I have a picture of some data points in blue, and in the beginning the mean is not 0 and it has a lot of spread. So for instance, the mean should be around here for the blue points, and we see that it is very spread out with a large variance. What the standard scaler does is to make sure that the mean here is in the 0, 0 point, and also that the variance should be 1. So you see that it's not as spread out anymore, but otherwise you see that it's a 1-to-1 correlation with each of the data points. So essentially what you see is the shape of the blue data points is exactly the same as the orange one. So the only thing that has happened is that it has been shifted around and scaled so that it has mean 0 and variance 1. So how do we do these kind of pre-processing steps? So first of all, let's start with the missing values. So if we have very few observations missing one feature, we can just drop them. And Pandas has this so-called drop NA, which we can use to drop all the observation with the missing value in this column here. So drop NA stands for drop not the number, or drop NaN values. And here we have said that in place should be true so that it actually drops the missing value in this data frame here. Another way to do it is to fill in the missing values with a specific number, for example the mean or something similar, which also works on Pandas data frames. So here we see that the value we will use to fill in all the missing values are 42, and we will do it in a specific column. And also here we will say that in place equal true so that it actually do the replacement. So this is the two ways we will fill in missing values. There exist other ones, but this is the ones we will use. Both of these functions come from the Pandas package. Okay, so next I wanted to just say how we do the standard scaler. So the standard scaler comes from the preprocessing module from Scikit-Learn, and it's called standard scaler, which is kind of fitting. And the first thing you do is to initialize a standard scaler object. Thereafter, you can use your scalar object to fit on the data, and also you can transform the data with the transform method. So here you see that we use fit, which you have seen before, and transform, which you have not seen before. And this is because standard scaler is not a predictor, because we do not use it to predict on new values. We use it instead to transform the data. And here we have a picture you have seen before with the estimator class, which introduced the .fit method. And then you have seen two different predictors, namely the linear regression predictor and the logistic regression predictor. And both of these have the .predict method. But standard scaler is not a predictor, but it is a transformer, because we transform the data to make it uniform. So all transformers have the so-called transform method, and it also have the fit method to fit on the data. Okay, so this was a quick introduction to some pre-processing steps. So let's start with the coding.